Hi, welcome to my video on proofs using properties of parallelograms. And this video will do some extra practice. The previous video I did some examples, and now this video will have more practice on using the properties of a parallelogram. And let's list the properties of a parallelogram. One of them is the opposite sides are parallel. Another one is the opposite sides of a parallelogram are equal. Another one is the opposite angles are equal. And the diagonals bisect each other. And another one is the consecutive angles are supplementary. So these are the properties that I'm going to use in these proofs. Not all the properties, but most of them. So if you want, pause the video and see if you can work these proofs out. Again, the proofs on quadrilaterals are a little bit harder than the proofs on congruent triangles, but you have to know the unit on congruent triangles in order to make the proofs on quadrilaterals easier to do. Let's do number one. ABCW is a parallelogram. Angle 1 is equal to angle 2. So ABCW. So here's the parallelogram right here. We got angle 1 is equal to angle 2. So how do we get that AB is equal to WT? Well, if we got 1 equals 2, then WC would equal WT by converse of the isosceles triangle theorem. And now, if I got WC equals WT, and I want AB to equal WT, that means I must get AB equal to WC, and they're the opposite sides of a parallelogram. So, there's my proof. Here we go. ABCW is a parallelogram, and angle 1 equals angle 2. So I'm putting the two of them into the first statement, into the given. Again, check with your teacher. So we have that if we got 1 equals 2, that means that WC is equal to WT, and that's CITT, converse of the isosceles triangle theorem, which means that if two angles are equal, the sides opposite those angles are equal. Number 3, AB is equal to WC, opposite sides of a parallelogram are equal. And as a result, we have WC is equal to WT, AB is equal to WC, so that means that AB is equal to WT, and that's the transitive property of equality. In other words, WC is here, WC is here, since WC is equal to WT and AB is equal to WT, that means that AB is equal to WT transitive. So there's one of them done. Let's do another one. Don't forget to pause the video and work them out. The more practice, the better. And again, we have a figure. We're given that PQST. PQST is a parallelogram. So we know the properties of a parallelogram. We're going to, hopefully, there they are. We're going to use those. And the C, VR bisects PS. So VR says VR bisects PS. So VR bisects PS, that means that PE is going to equal SE because of a bisector. So I have these two sides equal. So it says prove that PS bisects VR. So prove that PS bisects VR. So to get PS bisects VR, I need to get EV equal to ER. So how do I get EV equal to ER to get the bisector? I have to get PEV congruent to SER. So I already have these equal because of this bisector. So I need angles equal, and parallelogram gives me parallel sides, lines or sides. I got angles equal here and here. I also have a VOAT here. So I can get my triangles congruent, as you can see, by ASA, and we got these two equal. So proof done. I have it all planned out. Hopefully when you plan it out, you have to plan it out beforehand, because when you do, then you can write it up and it makes way more sense. But if you just start writing it up, then you could be in trouble by not putting it together at the beginning. So here we go. So we got VR bisects PS, so that makes PE equal to SE by definition of segment bisector. Okay, number 3, we have, let's go with angle 1 and angle 2. Angle 1 equals angle 2, and that's VOAT, vertically opposite angle theorem. Two lines intersecting, the vertically opposite angles are equal. And now we need PT is parallel to QS, and that's the definition of parallelogram. So that makes, that's the 1, 2, so let's make this a 3 and a 4. Notice I'm always use numbers. It makes the proof so easy to see. So 3 is equal to 4. That's the PLT, alternate interior angles equal. And number 6, notice we have 1 equals 2. We have these two sides equal. So we have the triangles are congruent. Triangle PEV goes with SER. And the reason it's P goes with S, because we said 3 was equal to 4. And that's an ASA congruency. ASA, angle, side, angle. And that makes, as a result, we have, we want to say PS bisects VR. So we have EV equal to ER. That's CTC and the congruent triangles. And because we have EV equals ER, that means PS bisects VR, and that's definition of segment bisector. Okay, hopefully everything is going okay. Hopefully you're getting a better handle on the proofs. So let's do another one. So we have Again, this figure, lots of segments. MTHF. MTHF is a parallelogram. So again, the properties. So you can put the properties. That's going to help you do your proof. We want to get OA equals ON. So we want OA equals ON. So OA and ON are in the triangle AOT NOF, or is in AOM is AOM is NOH. So which do you want to take? This triangle, going with this one, or do you want to do this triangle, going with this one? Well, let's see what we have. How do we get a pair of segments equal? Oh, I see that these are the diagonals. TF and MH are the diagonals. So we know the diagonals bisect. So that means I can say that TO equals FO because the diagonals are bisecting each other. So let's just do those two. And now I can get angle 1 is equal to angle 2 VOAT. I got parallel lines. So I can get 3 is equal to 4. Or I could put 3 and 4 here. But if I put 3 and 4 here, I would have an AAS. If I put 3 and 4 here, I got an ASA. So I got congruent triangles. So, yep, proof is all laid out. So here we go. Number 1, MTHF parallelogram. Given. So let's go with, let's see, we'd say that, okay, that OT equals OF, diagonals of parallelogram, diagonals of parallelogram bisect each other. And number 3, I have angle 1 equals angle 2, and that's VOAT. Number 4, I got MT is parallel to FH. Definition of parallelogram. And number 5, I have angle 3 equals angle 4, PLT, alternate interior angles equal. Number 6, so I have 1 equals 2, segments are equal, so the triangles are congruent, and I name the triangle A, O, T, and N, O, F. And that's angle, side, angle, congruency. And as a result, I have AO or OA. OA equals ON. CPCTC. And I just noticed here as the diagonals bisect each other, I could have wrote out here that that NH bisects FT right here, and then said that OT is equal to OF, definition of a bisector. So I just took a little one step quicker here. Okay, let's do some more. Here we go. Again, we're using the properties of a parallelogram. Here we go. I got this diagram. I have A, F, T, V is a parallelogram. A, F, T, V is a parallelogram. A is the midpoint of CFA is the midpoint of CF. I got to prove that AX equals VX. AX equals VX. So, if A is the midpoint of CF, A is the midpoint of CF, that means that AC is equal to AF. And I want to get that AX equals VX, so I might need to get these two triangles here congruent. So how do I get? I need at least one pair of segments equal. So how do I get? I can see the angles. I got angle 1 equals angle 2 VOAT. I can see this parallelogram here, and I got this side is parallel to this side. So I have angle C right here equal to this angle right here at T. So I need a side. So I know that this is a midpoint. How do I get this side? Oh, AF is equal to VT. Opposite sides of a parallelogram are equal. And since CA equals FA, that means that CA is going to equal to VT by transitive. And so I have my triangles congruent by AAS again. And this is a CPCTC. So here we go. Number 1. Let's write down the givens. AFTV parallelogram. And A is midpoint of CF given. So, number 2. Let's see, I can say angle 1 equals angle 2, VOAT. Number 3, I have A is a midpoint, so let's do that. AF equals AC, definition of a midpoint. If you have a midpoint, then the two parts of the segments are equal. And we have a parallelogram, so that means that AF is equal to VT because of opposite sides of a parallelogram are equal. And that means that if AF is equal to AC and AF is equal to VT, that means that AC is equal to VT. So AC is equal to VT, and that's a transitive property. Because in order to do congruent triangles, you need at least one pair of sides equal. So number 6, I need another angle. So I have that AF or CF, whatever you want. It could be AF or CF. You want to say AF is parallel to VT. That's the definition of a parallelogram. Opposite sides are parallel. That means that angle C is equal to, let's name this angle right here as 3. Angle C is equal to angle 3. I could have said VTX, 3 is better, and that's PLT, alternate interior angles equal. In other words, the Zorro. Notice I'm doing a lot of alternate interior with the properties of a parallelogram, but we'll do more corresponding angles later. And now we have 1 equals 2, C equals 3, and AC is equal to VT. So I have enough to have my triangles congruent. Triangles are CAF AX. CAX is TVX. TVX, and it's an AAS. AAS congruency, and as a result, I have two triangles congruent, so I have AX is equal to VX. CPCTC. Corresponding parts of congruent triangles congruent. Okay, again, hopefully everything is going okay. Pause your video and work out this proof. I set this one up a little bit different, and I'm going to put all my givens in here. So let's take all those givens and pretend that they are all written down right there. You can see them. I'm going to take them all and move them in right there. Then the next step. Now, how do I got OM is equal to BT. I have a perpendiculars. MH is perpendicular to OT. TA is perpendicular to MB. So perpendicular, let's put a perpendicular there and there. And say, why did they give us that? And MATH is the parallelogram. So this is the parallelogram right here. So how am I going to get angle 1 equals angle 2? Well, probably looks like they're in these two triangles here. OMH and BAT. So, or let's say MHO is going to go with TAB because A got to go with H. Okay. So how do I get? I could say that this angle, these are right angles and they're equal. Let's see. Okay, if I say they're equal, I got this side equals this. I got these two angles equal. Right, this angle right here equals to this one. And I got MH, opposite sides. So I have MH equals TA. So I got two sides and an angle. But notice if I say this angle at H and this angle at A equal, I have an ASS. Remember, an ASS incongruency is a no-no. So, if I say these are equal, then I can't do this proof can't be done. So I have to go about another way. So how do I do it? Well, because they're perpendicular, that means that this is a right angle at H, and this is a right angle at A. And because they're right angles, that means these are right triangles, because they're got a right angle in them. And because they're right triangles, that means that this triangle right here is congruent to this one by what they call hypotenuse, leg. Hypotenuse opposite the right angle and the leg. So now I can do the proof to get. So let's go with the given. So let's name this as angle 3 and angle 4. So let's say that they're perpendicular. So angle 3 and angle 4 are right angles. And that's the definition of perpendicular lines, because perpendicular lines form right angles. And as a result of having right angles, that means that triangle MHO and triangle TAB are right triangles. And that's the definition of a right triangle. Because right triangles have right angles. Now, because I have right triangles, I'm able to say HL, but I got to get the... So I have those equal. Now I got MH equals TA. Because I got a parallelogram, the opposite sides of a parallelogram are equal. Opposite sides of a parallelogram are equal. So I have MO equals TB given. These are equal right here. That's TA. So that means that the triangles are congruent. So the triangle MHO is congruent to MHO is TAB. Again, you have to match up the correct angles. And the reason for that is hypotenuse leg. It's a right triangle if the hypotenuse is equal and the leg's equal. And as a result, I have angle 1 equals angle 2. CPCTC. Again, different. It's an HL proof that we practice in congruent triangles. Remember, if you said 3 was equal to 4, you would have had an ASS, angle side side, and that's a no-no. This is what you call, I always say to my students, when you make a donkey of yourself, then you can't use it. And the other one you can't use in proofs is A. That's similarity. So these two you cannot use in congruent triangles. Okay, let's do the last proof here. We have ADEH parallelogram. ADEH is the parallelogram. I have HG equal to DC. So I have these two little parts of the segments equal. And I want to prove that NC equals NG. NC equals NG. And to get NC equals NG, I only have, this is the triangle, that NCA and NGE are the two triangles that have NC and NG in it. So how do I get these two triangles congruent? Well, here we go. ADEH is a parallelogram. And we have HG equal to DC. So, how do I get into these two triangles? Well, I notice that I know I got 1 equals 2 VOAT. I know I got parallel lines. So I can have angle 3 equals angle 4 here, or I can have angle 3 equals angle 4 here. I already got VOAT, so I only need one more pair of angles, but I need a side. So if this segment is equal to this one, given right here, I need to get at this side. Oh, the opposite sides are equal, and I have to do a subtraction. So if I have this side, AD, and I take off CD, I'm left with AC by subtraction. So if I get AC is equal to EG, then I have an AAS. So let's say that's 3 and that's 4. So now I have my proof planned. Here I go. So AD equals EH. This is the given. Opposite sides of a parallelogram are equal. So that means that AD is equal to AC plus CD, and HE is equal to HG plus GE. That's segment addition postulate or property, and as a result we have AD equals EH. AD and EH or HE. That means that AC plus CD equals HG plus GE, and that's transitive. Notice AD is here, HE is here. Since they're equal in number 2, therefore the addition of these two equals those two by transitive property. And we are given that HG, which is right here, equals DC, which is here, or CD. That means that AC must equal to GE or EG, GE or E. And that's subtraction. Or subtraction property of equality. We're subtracting off the CD and H. So if I subtract like that, I'll show you that these are the two left, subtraction. Now we have, let's see, do I have angle 1 equals angle 2? No. Angle 1 is equal to angle 2. VOAT. Notice doing the proof beforehand. Now do I have the parallel lines? Nope. So I have to say AD is parallel to HE. Opposite, or I could say definition of a parallelogram. Or I could say the opposite sides of a parallelogram are parallel, but it's easier to say definition parallelogram. That leaves me with angle 3 equals angle 4. These lines are parallel, so this is alternate interior 3 and 4. That's PLT, alternate interior angles equal. One thing about these videos, you should be able to see Z very easily, recognize it, alternate interior angles. And so we have enough now. Triangles are congruent, and let's name them correctly. NCA. So NCA goes with NGE. Again, N goes with N because 1 goes with 2. C goes with G because 3 is equal to 4. And the reason is an angle, side. AAS, this congruency. And as a result, we have NC is equal to NG. CPCTC, corresponding parts of congruent triangles are congruent. And that brings us to the end of more practice on using the properties of a parallelogram. And I hope you enjoyed the video. If you did, click the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.